This is lesson 9, graphing linear functions. Linear functions are the simplest types of functions, and understanding them is essential for learning more complex functions like quadratic, exponential, and logarithmic. By the end of this lesson, you're going to learn two things. One, you're going to learn how to graph linear equations given a table. Two, something totally new, is you're going to learn how to use a vertical line test to tell if a graph is a function or not. There are some things that you need to know to be successful in this lesson. First, you need to know what an ordered pair is. Well, an ordered pair, it's just a point on the coordinate plane. It's that XY thing that we've worked with before. A table, well, we've worked with tables before, but just as a reminder, tables are just another way to display ordered pairs or a relation. A linear equation, well, a linear equation, that's just a straight line on a graph. A function is a relation that has one output for each input. It's consistent. And lastly, a coordinate plane. Well, a coordinate plane, that's just a map for our ordered pairs. So let's get started. So graphing patterns, and this is just building on what we learned from last lesson. The only difference between last lesson and this lesson is we're going to take what we put on the table onto a graph. So here's the coordinate plane, and this one just has quadrant 2. Sometimes we need only one quadrant. Sometimes you'll use all 4. Just remember, as you progress in math, understanding when to use all 4 quadrants is important. That's just sort of a skill that you pick up along the way. There's never any real standalone lesson. What we're going to do is we're going to plot the points. So we're carefully put each point on this plane. You can get a copy of this from the slide notes, or this is also in the independent work. Both of these are available on the links below the video. So take a moment, analyze the table, and think about what you expect the graph to look like, and think about it before you put the dots down. That's going to trigger some learning. That's going to make you a better mathematical thinker. So go ahead, pause the video. I'll be waiting for you on the next slide. Hopefully that you notice the points or the ordered pair in the table just has the same information presented slightly different. The key about the table is a little bit more organized. If you notice the points, point D is -6, 9. The table, we start with -6, 9 because -6 is the smallest x value. The table always starts with the smallest x value in the x1 position. And whatever y goes with that smallest x1 goes in the y1 position, and then we fill up the table from the smallest number to the biggest number. Your task now is to plot the points. So carefully plot the points on the coordinate plane. Once you plot the points, connect the dots. You start with the points that are in the x1, y1 position, then you move from the x1, y1 to x2, y2, so on through the whole table. Just remember, it might not seem important now, but connecting the dots in the correct order will be crucial when working with more complex functions. So let's practice this skill now. Pause the video. The next slide will have the points plotted. So we got the points plotted. If you notice, I color-coded them. This is just to help make it easier. So here you got A, 0, 0. So this is point A, and then point B here. It's kind of the red one. The sort of white dot, that's point C, and then finally point D. I just color-coded it to make it easier for you to check your work. Do your dots look like this? Now, we hadn't connected the dots, but what do you think is going to happen when we connect the dots? What kind of line are we going to have? Go ahead, pause the video, connect the dots. If you hadn't done so, the next slide is going to show you what it's going to look like. In here, we've got a straight line. The arrow here just means it could go on and on forever. We could add an arrow on the other end. A common question is, how do you know when to have an arrow or not? Well, it just depends on the situation. When in doubt, always use an arrow. You shouldn't ever be counted off for using an arrow because mathematically things can go on forever. But if this was a real life problem and we're talking about how many gallons of gas we have in a gas tank, if we're filling it up, well, there's a maximum amount you can put in that gas tank. If you're emptying it out because you're driving, well, there's a maximum distance you can go based on the gas, or there's a maximum amount of gas that you can burn while you're running the car. So the real life situation, the context of the problem, otherwise just put the arrow. So now we're going to just practice. Before we put maybe just one dot on, so let's practice one more. How do we plot these points? Just think about it. And so plot the points, and then once you plot the points, we'll connect the dots. So go ahead and pause the video while you plot the points. When you plotted the points, did they look like this? So if we call this A, we got red A here. We'll call this B, we got B here, and finally C. So your points should look like this. If not, pause the video, compare your work to my work. Just double check the ordered pairs in the table. Once you do that, connect the dots. When you connect the dots, you'll have a linear graph. Here's our line. Once again, it's a straight line. So the question is, and I've sort of gave it away, but that's okay. Is this linear or nonlinear? Is this a linear function or a nonlinear function? Just looking at the line here, what do you think? Yeah, you should say, oh, it's linear. Because it's a straight line. Straight lines are linear. Also, over here, we have a constant rate of change of 3 in the x and 2 in the y. So mathematically, we can prove that this is a linear function because we have a constant rate of change among our x values and a constant rate of change among our y values, and we see it's a straight line. And we've already found that rate of change, but once again, it's just highlighted a little bit better. It goes up 3 times. Over here it goes up 2. A common question is, what would come next? Well, what would come next is on the x, we would have 6. On the y, we would have 5. And we could do this forever and ever. Now, we've already established this is a linear function. And we used the table, and we found a constant rate of change, and we see that it's a straight line. Sometimes, especially with nonlinear functions, we may be given a graph, and the question is this a linear function, or is this a function or not? If it's a straight line, it's linear. But we have this thing called a vertical line test. A vertical line test is just a vertical line like this. If it crosses just once, like we have here, it's a function. If it's more than once, it's not a function. We're going to look at some examples, but just remember, if you draw a vertical line, just straight up and down, parallel to the y-axis, and it touches only once, it's a function, each and every time. Here's an example of the vertical line test. I used my little PowerPoint, and I made better straight lines. Notice all of these vertical lines are all parallel to the y-axis. And anywhere I put this vertical line, or a vertical line, it will touch just once. And I could put an infinite number, right? There is no limit except for how small my pencil tip is. But notice, anywhere we put it, it just touches once. So it's going to be a function. There's going to be some questions about whether or not a graph is a function. And we use a vertical line test to let us know if it's a function or not. This is taken from your independent practice. Just want to point out the red line here, right here, these red lines are the vertical line. Notice in this one, this is not a function. It's not a linear function. Right now, we're just going to call it a nonlinear function. This is something you would probably see in Algebra 2 or trig. But that's outside the scope of this course, which is why we're calling it a nonlinear function. Just know if you go far enough in math, that function will have a name. This one, it's a linear function. It's a straight line. We've already talked about that. Touches once. This little curvy thing here, it touches twice, so it is not a function. And guys, the vertical line test is just that easy. It touches once. If it can only touch it once, it's a function. We may not know the function name, and that's okay. We just need to know whether it's a function. If it touches it more than once, it is not a function. So this one right here, think about it. Draw a vertical line. Is this a function or not? Yes, it is. I drew, notice I put through like 3 vertical lines. Not, I mean, it is a function. It's a function because each line touches only once, right? Touches only once. Let's look at another example. Here's another example from your independent practice. This looks like something we've seen before, which is okay because in mathematics, repetition is the key to learning. You get good at math through practice, but this is a linear function, and we know linear functions will always pass the vertical line test. As you can see here, I drew 3 vertical lines. Each time touches only once. One touch equals function. Let's look at another line. What about this one? This one confuses some students because, yes, it's a straight line, but we don't really consider this linear. I mean, even though it is a straight line, because when you put a line on top of it, it touches, well, we can just count. I mean, it's going to touch an infinite numbers, but just for fun, we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17, 18, 19, 20. It's at least 20 touches, right? So it's not a function. And this right here is on just about every standardized test. So I drew this purple line, and you see how the purple line covers the red graph? So it's touching several points here. It's touching it in an infinite number of points. And if this was a equation, it would be like x is equal to 1, 2, 3. So whenever x is equal to a constant, it's not a function. Now I'm going to keep mentioning this throughout the course. X equals to a constant, like pi is a constant. If x is equal to an ordinary looking number, it is not a function. It is what we call undefined. Does this pass the vertical line test? Yes, it does. I put 2 lines here. Each time I touch once, but once again, I can put an infinite number. In each place, only one touch. So it's a function. If you see the equation for this, well, here y is equal to 1. So it would be like y is equal to 1.2. Sometimes you may be asked a question to estimate, so that would be good. We know it's not halfway, so any number under 0.5 will get you the right answer. Sometimes standardized tests like the ACT, state exams, they'll put a letter, like in this case, a letter X, and they'll ask, hey, is this a function? Does it pass the vertical line test? What do you think? Is it a function? Would these inputs have more than one output? Let you think about it for a moment. Yes, the letter X has multiple places. And even if it was just a regular X, not filled in like this one, would still have more than one touch point with the vertical line. I just like to point this out because every standardized test I've ever seen has at least math standardized test has at least one question. Is this letter, is letter X a function? Is letter P a function? So here's a few more, and you may want to pause the video while you think about this, but which letter passes the vertical line test? So you got A, V, P, W, Q. For fun, if you want to do a little extra, you may want to go through the whole alphabet. It won't hurt you, it'll only help you. But pause the video for a moment and think about it. The next slide will have the correct answer for you. Here's the answer. Well, the letter A is not a function. I'm going to write NF for not a function. On your work, you can write N/F if you want for not a function. Letter V, anywhere you draw a line on the letter V will touch once, so that is a function. P will touch twice here. And I put it here because I think that's easier to see than if you drew it down here to where it would be infinite. But once again, that is not a function. The letter W, anywhere you draw a vertical line, it's going to touch once. So that's a function. And the letter Q is for sure a function. Later on in this course, you'll see what's called a quadratic. Graph looks sort of like that. It's going to look like the letter U, so that's a good little bit of foreshadowing. So now we're going to graph a table. So we're going to take what we've learned in terms of graphing from a table and the vertical line test, and we're going to do them both in the same problem. This is a good example of how mathematics builds on itself. So we did two things in isolation. Both of them are easy. Now we're going to do two things in a given problem. And to keep things easy, just do it one at a time, because graphing was easy. Vertical line test is sure easy. So we're going to graph the points. So we're going to carefully plot the points from the table onto a coordinate plane. Then we're going to apply the vertical line test. We're going to draw, you can draw it or you can use an imaginary one. When I'm learning something new mathematically, I like to write everything out. So you may want to go ahead and draw that vertical line just to increase your mathematical memory. Then we're going to compare it to the table. Does what we see on the graph match what we see in the table? And just always remember, the vertical line test is just a visual way to check to see if each input, x value, has exactly one y value. So graph this table, pause the video as you graph this relation, and the answer is going to be on the next slide. So your dots, they should look like this. Once again, I color-coded them. So this, for fun, we'll call this A, B, C, and D. So A, that's B. I'm just double checking my work here. So A is 0, 1. B is 2, 4. C is 4, 7. And D is 6, 10. One thing I like to do is, especially when I'm double checking my work, so I like to just make these little notes on my paper. The more notes you make by hand on your paper, the more the stuff's going to stick with you. If your points don't look like this, you should double check your work, pause the video, and fix any mistakes before you move on to the next slide. So now we plot the points. And when I plot the points and I draw my line from starting with x1, here we go, forms a straight line. Go ahead and put my arrows on because it could go on forever and ever. If you don't put the arrows on at this point, it's not a huge deal because we're just limited to what's in the table. I just like to do the arrows because that's just what I do. And if we were to draw our vertical line, it's just once, one time. So it's a function. Let's look at our look at our next. We've got another example here. So what I like to do before I graph is I just look at my points. We'll call this A, B, C, D, and I think about, well, where's 0, 1 going to be? And I think about where 2, 4, 2, 7, negative 8, 7. So I kind of get an idea of what my work should look like. I'm anticipating. And then I know I'm going to be asked whether or not it's a function. Does it pass the vertical line test? I can tell from looking at the graph whether or not or the table. I can tell from looking at the table if it's a function or not. So go ahead, pause the video, plot those points, connect the dots in order, and we'll compare answers. Okay, you should have plotted your points. So once again, I'm going to call this A, B, C, and D. So here for A, well, that is 0, 1, so I know that's right. B here is 2, 4, so that's B. C is 2, 7, so that's correct. And I go all the way over here, and to point D, I have negative 8, 7. So I know they're all plotted correctly, so double check your work. Now think about the vertical line test before we draw it, and whether or not you think it's going to pass. Pause the video while you connect the dots. Got the dots connected. When I drew this, I started, because it's my x1, y1, went from x1, y2, up here to x3, y3, and finally to my last point. So does this pass the vertical line test? It does not pass. It is not a function. Of course, we know from here we have 2 with 2 different outputs, so that means it's not a function. This vertical line at this point touches 2, but if we were to draw it here, it would touch at an infinite number of places. 1, 2, 3, 4, 5, 6, 7, 8, 9. I did 10, so 10 is way more than 1, but we know it would touch it at an infinite number of spaces. So with graphs like this, what I like to do is I like to look for what I would consider an easy to test region. And that's sort of a subjective thing. It varies from one person to the next. And let's just recap. Got enough information to complete your independent work in the online practice. Just to recap, we use the x and y coordinates to plot points. It's our directions. It's our map. We connect the dots according to their table location. So we start drawing the graph at x1, y1. Then we move over to x2, y2, x3, y3, so on until we run out of points. If a vertical line touches the graph just once, it passes the vertical line test. If it touches it more than once, it fails the vertical line test. So there's no gray area. Once passes, more than once fails. A vertical line will touch it in an infinite number of places. So if you count more than one as you're trying to think through it and you get like 20 places it touches, it fails. It's not a function. X equals a constant always fails, and that's what a vertical line will look like. Y equals a constant always passes. So if you have any questions, just drop them in the comments. I'd be glad to help you. And good luck with your online practice and your independent work.